verifying equation solutions. All of these things are different types of equations that you're going to be able to handle eventually in Algebra 1 class. We've got simpler equations like this that you'll see when we get to skill number 10, so a few class periods from now. Tougher ones like this that we won't get to till later, and even tougher ones where you've got two sets of equations with two variables that we'll get to even farther down the line than this. Okay, so different types of equations. Now, we're going to be able to use all of these types of equations to do what I'm going to ask for today. All right, what I'm going to ask for today is yes or no question. All right, is this g equals 19 the solution to that equation? And if you're going to tell me yes, you have to prove it. And if you're going to tell me no, you have to prove it. Right? It's not that tough to prove. This is what we do. We just try it. Right? What if g is 19? Then this would say 3 times 19. Right? I'm replacing g with 19 plus 54 equals 117. Now, since I'm not sure if it's true, I put a question mark above the equal sign. All right, that lets me know I'm testing, are these equal? Right? I don't have to do any math over here. I'm going to do some math over here. 3 times 19, 60 minus 3 is 57, plus my 54. All right, 57 plus 54 is 111. So, does 111 equal 117? Well, they're close to each other, but they're not equal to each other. So is g equals 19 the solution? No. Prove it? I just did. All right, that's how this is going to work. All right, same kind of thing. Is h equals negative 36.4 the solution for this? Now, this will be a little bit more complicated to prove or disprove because I'm going to have to do some math on the left and I'm going to have to do some math on the right. And there's a decimal in here, but calculator is allowed. Okay, so our first move will be similar to what we've done in lesson 3 and lesson 4. Replace the variable with this number we're going to test. Right, so we've got 8 times negative 36.4 plus 11 minus 2 times negative 36.4. Does that equal, question mark, 4 plus 7 times negative 36.4, all of that over 2. I'm going to simplify on the left-hand side, so we're going to handle what's in parentheses. 8 times negative 25.4 minus 2 times negative 36.4. I'm going to do both of my multiplication steps. So 8 times this, that's 8 quarters, which would be $2, so 200. And I also have to do 8 times 0.4, so we've got negative 203.2. All right, again, use a calculator if you need to. Minus 2 times this, that's going to be negative 72.8. All right, lastly, I'll do my subtraction, which, remember, keep switch, switch, right? So this is actually like an addition problem. But since they're opposite sides, I'm gonna have a negative answer, but this negative answer will be reduced by 72.8. All right, so I'm actually gonna use the calculator for this. Negative 203.2 plus 72.8, and we get negative 130.4. Now, I feel like I'm done. All right, I got an answer. Okay, but I'm not done because my question is, does this answer match what's on the other side of the equation? Okay, so over here we've got 4 plus 7 times negative 36.4, which is negative 254.8. All of that over 2. I'll do my addition. 4 plus this. All right, it's going to be, switch colors, negative 250.8 over 2, which is going to be negative 125.4. All right, not equal to that. All right, so once again, my two things do not match. That means that negative 36.4 is not a solution for this equation. All right? No. Keep in mind, just based on probability, there being only one possible correct answer and infinitely many incorrect answers, chances are the answer is going to be incorrect. But when textbook writers and test writers and teachers write problems, we try to make things work out nicely. So you're going to see a good mix of things that do a good mix of yeses and nos for your answers. Okay. One of the beautiful things about being able to verify equation solutions is when you have to deal with a SAT or a Keystone exam or a benchmark or a standardized test of any sort where they give you multiple choice answers. If you have a complicated situation, but it's got an equal sign in it, you don't actually have to necessarily know how to do all the mathematical steps. You can just do what's called guess and check, which is essentially doing what we just did. All right, I'm asking, is 2 the answer to this? Yes or no? Is 10 the answer to this? Yes or no? Is negative 6 the answer to this? Yes or no? And I know, multiple choice, one of these has to work. So I could just try things. I'm going to start with my 18. All right. If I replace n with 18, then doing some math in my head, 18 minus 1 is 17 plus 13. Does that equal 3 times 18 plus 19? All right, we do our math on each side. 4 17s is 40 plus 28, 68 plus 13, that is 81. Does that equal 3 18s is 60 minus 6, 54 plus 19 is 73. All right, no. Okay, 81 doesn't equal 73, and I got that answer by using n equals 18 in that equation, so I would say no. N doesn't equal 18. Let me try n equals 10. All right, 4 times 10 minus 1, that's going to be 4 times 9. Plus 13. Does that equal 3 times 10 plus 19? Four nines is 36. 36 and 13 is 46, 49. Does that equal 3 tens is 30. 30 plus 19 is 49. We have a winner, right? If n equals 10, it makes this equation true. And look, I didn't do any sorts of complicated combining like terms, opposite operations, all of the things that you're going to learn how to do when we deal with this kind of problem and you don't have answer choices. I didn't have to do any of that complicated thinking. I'm just checking the possible answers that are there. Okay, and this is my expectation for this topic, that you'll be able to verify yes or no, is an equation correct. Like I said, tag on to this. I'm also expecting, because it's so easy to do this, you will never get a multiple choice question wrong on any kind of test that you take if there's an equal sign in it. Right? If you have an equal sign in your equation and you have multiple choice answers, you should not get that type of question wrong. The way that guess and check works with an open-ended question is you try numbers. Right? So maybe I would say, what if W is 3? Will it make this equal 34? All right, and we've got 7 times 3, 21, plus 3, 24, divided by 2, 12, plus 8, 20, does not equal 34. No, 20 does not equal 34. I think I want to make this side bigger, so I'm going to have a second guess, and it's going to be larger than 3. So maybe I will try 13, right? Does W equal 13? 7 13ths is a big number. 70 and 21 is 91. 91 plus 3 is 94. 94 divided by 2 is 46. Can't keep track of all this in my head, so I'm going to have to write some of it down. All right, 3 plus 91 on 2 plus 8. That is 94 on 2. 94 on 2 is going to be 47 plus 8 is 55. All right, 55 doesn't equal 34, and this time I'm too big. All right, so I know that my answer is between 3 and 13. All right, and you could keep trying things until you eventually came to an answer. We're going to go with this one. I think this one's going to work out, actually. 7 times 7 is 49. 49 plus 3 is 52. 52 divided by 2 is 26. 26 plus 8 is 34. This one will work. Okay? That's how guess and check works. All right? Again, you don't have to do the math in your head. You can use a calculator. You write down steps, okay? You do have to leave a trail of these are the things that I've tried, these are the results that I got, okay? Whether you're doing stuff in your head or on paper, you have to leave a trail of your thinking, all right? That's guess and check. Now, lest you in a later date say, why can't we just guess and check always? Remember, sometimes your answer comes out as a decimal or a fraction. If the answer to this had been 2.941, you're not going to guess that for like a year. You would be sitting and working on the problem for pages and pages and pages of guesses and checks, right? So we do want to eventually come up with some other strategies for dealing with stuff like this. But for now, what you're working on is try a number, whether you're choosing the number, guess and check, or I'm giving you a number to try, verify, does this number work or not? One last thing to go over with this topic. If you have what is called a system of equations, meaning 2 equations in the same problem that are using the same variable values, a solution, in order for something to be a solution, it has to solve both of them. So for example, 2 times 2 is 4 plus 0. All right. So if I said is x equals 2, y equals 0, a solution to this system of equations, right? This works for the lower equation. 2 times 2 is 4, plus 0 is 4, okay? But you also have to test it for the upper equation, right? 3 times 2 is 6, minus 0 is not 11, okay? So this works for the lower equation. It doesn't work for the upper equation. What that means is that no, this is not a solution, right? You need 2 yeses in a situation like this. It's not allowed to work for one, but not work for the other, okay?